Okay, so we're making copper, apparently, at the cathode of an electrolytic cell, and they ask how many coulombs of electrons have passed through the cell. In other words, how much charge has passed through the cell. Now, I believe we've had some other examples where they asked which of these cells consumes the most coulombs, and we kind of got around that by just working out moles of electrons and saying which one of these consumes the most moles of electrons. But in this one, they actually want a quantity of charge, and so we can't use that dodge anymore. We're going to have to do something different. And the it is funny formula will kind of help us here. We're just going to have to use it in an unusual way. But to get ourselves started, let's figure out what reaction we're doing and get some other basic information sorted out. We're producing copper from copper 2, so the reaction that's happening is copper 2, and it's turning into copper metal, which makes sense if we're adding 2 electrons here, so we're reducing copper 2. And they told us there's 50 grams of copper, and the only point of telling someone grams is if you want them to get moles, at least if they're a chemist. So number of moles is mass divided by molar mass. 50.0 grams divided by copper is 63.55 grams per mole. 50 divided by 63.55 gives 0. It's going to be a 3 significant digit answer, so I'll carry 5 digits. That should be plenty. 0.78678 moles of copper being made. Now, we can find how many electrons that is because we have a formula that tells us however much copper you're making, you'll need twice that many electrons, 2-to-1 ratio. So if we take that number and double it, we get that our number of moles of electrons is 1.5736. Still getting 3 or 5 significant digits. Okay, now I've kind of encouraged you to set this formula up anytime you have any kind of electrolysis problem, and that's generally good advice, but we can't just blindly apply the formula here because we have a number of moles of electrons, we have the Faraday constant, we don't have a current or a time, so we're a little bit stuck there. And anyway, current and time are not what we're looking for here. We're looking for charge. But good news, the formula still kind of helps. There are 2 formulae we've given you for finding Q, for finding charge. One of them is Q equals IT, which some people remember as the quit formula. You can find charge by doing current times time. Sadly, we don't have either one of those. The other formula that can get you charge is Q equals FNE. And we have both of those things. We always know the Faraday constant, and we have our moles of electrons, so we can use this to find charge. In other words, both sides of this formula, when it's written in this form, give you Q. You can do the left side, IT equals Q, or you can do FNE equals Q. So that's fairly nice. This formula, even though it isn't configured for finding charge, each of its sides can get you charge if you just take it in isolation. So that side equals Q, or this side equals Q. So even when this formula isn't the right one, it still manages to help us because it's awesome. So in this case, if we're finding charge, we can do the Faraday constant, 96,500, times our number of moles of electrons, which we just got, 1.5736. And so doing that, I get the charge is, where's my decimal there? 151,848, or I guess it rounds to 151,849 coulombs. Now the bad news, this answer should only contain 3 significant digits. And 3 significant digits isn't enough to write 151,000, so I have to, well, I have 2 choices. Either I can go to a bigger unit, or I can go to scientific notation. In scientific notation, this would be 1.52 because I'm only keeping 3 digits, and then I look at this 8. This is 5 or more, so I round up. I can say 1.52 times 10 to the 3 coulombs. Or, I'm sorry, 1.52 times 10 to the 1, 2, 3, 4, 5 coulombs. Or the other option is I could say 152 kilocoulombs. Awkward unit, but it does work. It's metric. A kilocoulomb is 1,000 coulombs. So take this number, divide by 1,000, round it properly, and you get 152. All right, so charge is hard to measure, and so we don't care about it very often. Generally, we're more interested in moles of electrons because we can measure those by seeing how much chemical forms, or we can measure current, which is easier, and multiply it by time, which is also easy to measure. So it's rare to get a question where we ask you for Q. But if you need Q, just remember the it is funny formula can give you 2 ways to find Q. The left side equals Q, or the right side equals Q, whichever you find easier.